class representative from your branch. Hello, Dhanraj. Hello, Dhanraj. Hello. Anybody please start your mic. Mic કોઈ પોતાનું open કરો અને discuss કરો. I am new in this class, so first we need to discuss something and then we can go with the new topic. Hello. Dhanraj, can you start your mic? Hello. Parth. Yes, Parth, can you start your mic? Okay,
yes, sir.
so what is the topic, last topic, which is taken by Shreyas sir? I think he has told me about AM modulation something.
Yes, sir.
Okay, so all of you having your multi-SIM in your laptop or in your device? How many of you have a multi-SIM? Those who have the multi-SIM right now available in your device, please write yes in chat box. Hello? Parth? Yes, Parth. Everybody saying no, 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 no. So how you are doing your previous experiment? Hello? Parth? How you are doing your previous experiment? Can anybody reply me, please? Hello? Monil, Ronak, Rusi, Sakshi, San, Srenik, open your mic, please. Hello?
હા સર બોલો.
એ શ્રેનિક, કેવી રીતે તમે લાસ્ટ એક્સપેરિમેન્ટ કર્યા હતા?
મને કઈ આમાં નથી એટલું બધું ખ્યાલ, કારણ કે હું ન્યૂ સ્ટુડન્ટ છું સર, તો મને કઈ આમાં ખ્યાલ નથી સર.
ઓકે, D2D સ્ટુડન્ટ છો?
હા, D2D છું.
ઓકે, બીજા સાન, સાક્ષી,
Yes, sir.
રુચિ, ઉમંગ.
સર શ્રેયસ સરે એક મેડમ ના નંબર આપ્યા હતા કે ડાયરેક્ટ માં મારવાડી થી કનેક્ટ કરાવ્યું હતું.
ઓકે, તમે અહીંયા લેબમાં કરતા હતા ને એવી રીતે
હા,
એક્સપેરિમેન્ટ?
એવી રીતે.
ઓકે ઓકે, તો કેટલા લોકો પાસે લેપટોપ છે અત્યારે? હેલો, કેટલા લોકો પાસે લેપટોપ છે? એવરીબડી? હેલો, આપણે એક પછી એક સ્ટાર્ટ કરીએ. ધનરાજ, ધનરાજ, યસ ધનરાજ.
યસ સર.
લેપટોપ છે તમારી પાસે? અત્યારે નથી, ઓકે, પણ છે તો ખરું ને?
યસ છે સર, પણ અત્યારે નથી.
ઓકે, તો પહેલા આપણે એવું કરીએ કે અત્યારે જે એક્સપેરિમેન્ટ આપણે કરવાનો છે એની થિયરી અને જે વસ્તુ છે એ હું તમને અત્યારે એક્સપ્લેન કરું. પછી જે લોકો પાસે લેપટોપ છે તો મારી પાસે એક સોલ્યુશન છે કે રાઈટ નાવ મારી પાસે જે એક્સપેરિમેન્ટ આપણે કરીએ છીએ એનું સેટઅપ મારી પાસે પડેલું છે, બરોબર? તો એવી વસ્તુ થાય કે હું એ સેટઅપ તમને શેર કરું અને એ તમે 450 કે 500 MB ની ફાઇલ છે, તમે ડાઉનલોડ કરી અને તમારા સિસ્ટમમાં કેમ ઇન્સ્ટોલ કરવું એ પણ હું તમને સમજાવું. અને નેક્સ્ટ ટાઈમ જ્યારે આપણે ભેગા થઈએ ત્યારે તમે લોકો એ તમારા લેપટોપમાં સેટઅપ કરી અને આવો. Is it okay, everybody? થઈ શકે આવું? જેનિસ, માર્ગીબેન?
સર
બરોબર.
હેલો
ઓકે, પાર્થ
હેલો
તમારું હાજી બોલો મિશલ.
સર એ વિન્ડોઝ માટે જ છે
હા, વિન્ડોઝ માટે છે.
એની સોલ્યુશન અબાઉટ ઉબુન્ટુ
મેક?
ઉબુન્ટુ
ઓકે,
લિનક્સ
તો મેક માટેનું પણ સેટઅપ હું ટ્રાય કરું. અત્યારે તો વિન્ડોઝ માટે છે. અને જે પેલા મેડમ આપણે એના નંબર આપેલા હતા એ પણ તમે અહીંયા લેબમાંથી એક્સપેરિમેન્ટ કરી શકો છો. એ પણ એક સોલ્યુશન છે. પણ ફર્સ્ટ ઇનિશિયલ ટાઈમમાં હું પેલા તમને સમજાવી દઉં કે તમારે એક્સપેરિમેન્ટમાં કરવાનું શું છે. પછી હું એક સેટઅપ મારી પણ સિસ્ટમમાં હું સેટઅપ કરું છું, જેથી એ પણ તમને બતાવી દઉં, તો જેથી તમને આ વિડીયો રેકોર્ડ થઈ જાય અને તમને યાદ રહે કે ભાઈ આવી રીતે સેટઅપ કરવાનું છે. તો તમારી સિસ્ટમમાં જ્યારે તમે એ સેટઅપ કરો, like I will give the setup to you, as well as this video is also going to be recorded for that particular setup. And once that lecture is going to be over, you can see this particular video on your YouTube portal, and according to the step you can follow for the installation. So better in next time you will come with your laptop and you will do the experiment along with me. Is that okay? તો આપણે એવું કંઈક સ્ટાર્ટ કર્યું. Okay, we are going to start in that particular way today. Okay, because it's a first lab of mine, so it's necessary to do the installation and all stuff first. Is that okay?
ઓકે સર.
Okay. So let me start with first of all myself. Anybody is knowing me or not? Are you aware with me or not? Might be not, because I have taken some of the class in Syria and some of the class in TC1 in last semester, digital electronics and basic electronics. So first of all, let me tell you about myself. I am Vishal Sorathia. I am from Information and Communication Technology Department, and I am here since 7 years. I have completed my masters from the Marwadi University only, and recently I am pursuing my PhD in same Marwadi University right now. And I have taken this subject since last 3 years, and now there is according to that lecture allocation, Shreyas sir is not able to take this particular portion, so he has another lectures and load. So I am taking your lecture right now from today onwards. Okay, so entire kind of the evaluation, your canvas evaluation, your quiz, your marks, your unit test, your every type of the kind of the evaluation is going to be done by me from today onwards. Okay, so whatever the query related to the DCN subject from your class, you can contact me and you can write down to me in that my mailbox, or you can ask the question in Canvas also. Or if you have any doubt, then I will also leave my number, so you can contact me on that particular number also. Okay, so let me start with this. First of all, we will see what is the stuff that we are going to discuss. Okay, then after we will go with the setup process, and then I will give the task that you are going to do, and then in the next lecture onwards we will continue with our regular flow of the amplitude modulation practical. Okay, so I'm sharing my screen now. Just notify me once you will see the screen. Okay, is that the screen is visible? Hello?
Yes, sir.
Visible. Okay, okay, good. Yes, so this is the experiment we have. Like in this experiment, we have to perform the amplitude modulation and demodulation using AM transmitter and receiver. So as you aware about that, do you know about the AM first of all? Now, one thing that I need to be clear over here, it's not like that one-way communication. Whatever the stuff you are knowing or not knowing, or you are saying, sir, we don't know about the AM, we don't. So I will repeat that stuff also, okay, again. But you need to give me the answer, whether you are knowing or not knowing. Otherwise, I will speak, and if you don't know about that stuff, so that entire concept is going to be on vain. Okay, so please reply. First of all, Does anybody tell me what do you mean by AM? Anybody? Any idea? Any stuff? Any answer? Can you tell me what is AM? Hello? Any idea about that? What do you mean by AM? If I'll ask individually, please, or anybody, is that anybody know this AM is covered or not in regular classes? Dwarkesh, Jai, Janice, Margi Ben, can you give me your feedback whether this topic is covered in your regular lecture or not? Hello? Hello? Dwarkesh, Dhanraj, can you please give me a feedback? Speak something. Entire class is not speaking anything. What's the issue, man? Not anybody is giving me any feedback. Yes, no, covered, not covered. You know, don't know. Such type of the stuff you can share, please. If you are not speaking anything, it means you are not want to attend this session. Am I consider your absent is over here, like not participating anything? What's the issue? Please share frankly. What's the issue? Why you are not responding anything? Don't know, sir. Okay, Rusi is saying don't know. Any other students? Some students are saying yes, sir. He knows. So who knows? Can you give a brief about that? What is AM modulation? Amplitude modulation. Can you tell me detailed on what do you mean by AM modulation? Can you speak up? Okay. So maximum students don't want to give their feedback and just sitting the idea. No issue. Let me start with this one. Okay. So what is the stuff we have? Like if you don't know about the AM modulation, again I will repeat that. What is AM modulation and what are the stuff over here? So AM modulation, which is generally known as amplitude modulation, and the name itself suggests that modulation on the amplitude. First of all, this is a modulation technique for the analog signal we have. We are having a two type of the signal. We have digital signal and analog signal. Consider that at your physical layer of your OSI layer architecture. In OSI layer architecture, at the physical layer, let's consider there is a digital signal is coming. And second scenario, consider that there is an analog signal is coming. So if there is a digital signal is going to be coming, and if you are modulating that particular stuff. Now, first of all, why we need to modulate? Because of the modulation, you can send your signal through the longer distance. Okay, and your signal is not going to be attenuated that much because it's going to be modulated on the high frequency. So as the frequency is going to be higher, signal is going to be less attenuated, and due to these advantages, modulation is going to be primary requirement to send the signal through the longer distance. Now, once you have decided to send the signal to the longer distance, it is necessary that you need to do any type of the module. You need to apply any type of the modulation technique on your digital signal or in the analog signal. Now, if you are using a digital signal, then the modulation technique is going to be like ASK, FSK, PSK, QPSK, QAM. So these all are the modulation technique which is applied on the digital signal. Like ASK, it means amplitude shift king. FSK, it means frequency shift king. PSK, it means phase shift king. QPSK, it means quadrature phase shift keying. QAM, it means quadrature amplitude modulation. So such type of the different modulation technique which is applied on digital signal. If we are talking about the signal which is analog as an output, okay, and if you want to modulate those signal where data is going to be analog, so that modulation technique will be AM, FM, and PM, okay, which is similar as a ASK, FSK, and PSK, but over here data is analog. That's why we are having a modulation scheme is AM, FM, and PM. So out of that, AM we are going to discuss over here. AM is nothing but there is amplitude modulation. And first of all, why we required the modulation? So message signal cannot travel through a longer distance. Because of that, we required the modulation, as well as that lower signal strength is going to be happen if you are sending your signal through longer distance. Let's consider right now, if you are just speaking with somebody else, okay, if that person is just near to you, like 5 feet or 10 feet, so you can easily convey your message, okay. But if there is a same audio you are speaking over here, and if you want to transmit the same audio signal at the 100-kilometer far away, so with the simple that audio signal, it is not possible to send that much of the longer distance your voice. Okay, your voice cannot be transmit to that much of the longer distance. So for that, what you are required? You are using such a modulation technique, or you are using one carrier which can carry your voice and it can transmit through a longer distance. Okay, best example for this particular stuff, which is your FM radio. You can say all the station is broadcasting on the different frequency band, okay, like 98.3, okay, 94.7, 92.7, different frequency band is there, or different radio band are there. So all of them are transmitting audible information, okay. They are transmitting their voice signal, any song or any particular advertisement, which is in terms of the acoustic range. Okay, that acoustic range, it means audible range. Okay, so that audible range transmitted through the different radio station, and the different radio station having the different modulation frequency. Okay, and due to that modulation frequency is in megahertz, you can send those signal through the longer distance. In entire city you can transmit your voice if you are doing a FM modulated signal on your particular voice. Okay, so message cannot travel through the longer distance because of the low signal strength. That's why we need to do the modulation. So high frequency or high energy signal called the carrier signal, which is actually going to be used to transmit the such amount of the high signal. Okay, that's the stuff we have. A high energy signal can travel through a larger distance without getting affected by the external disturbance. Okay, as much your signal is going to be higher in terms of frequency or in terms of the higher amplitude, it can travel through a longer distance. Okay, that's the basic rule we have. Okay, in the any particular signal transmission. Okay, so higher energy signal can travel through a larger distance without affecting any external disturbances. Modulation means to change. Okay, it means it's to change their shape, their frequency, their phase in such a manner that it can travel through a longer distance. So what is going to be changed, that we need to discuss over here. Okay, so another advantages of the modulation or need of the modulation, that it will avoid the mixing of the signal. Like as the example I have given about the FM, let's consider that two particular radio jockeys are there, which is speaking their speech or sharing some information, both having the same audible range. If you know that, for your information, whatever the voice that you are generating from your mouth, which is in between 20 to 20 kilohertz, okay, your audible signal, which is ranging from 20 to 20 kilohertz frequency, okay. So it is common for all the human being, like all the human being can transmit signal maximum up to a minimum from 20 hertz maximum to 20 kilohertz. So if we can say two particular person are speaking simultaneously, now to avoid that mixing of the both of the signal, you are using a modulation for the different frequencies. So you can transmit that signal with the different carrier, and both is not going to be not going to be interfere with each other. So that's the one advantages we have of the modulation. Increase the range of communication. Like if you are doing the modulation, you can increase your range in drastic in manner. Like whatever the stuff I'm speaking right now, if I'm doing a FM modulator and if I set up the tower at the kind of the top of my particular home roof, I can transmit that signal through some kilometer also. Okay, and you required one particular radio which can tune that frequency and you can hear my voice. So we can say by using a simple modulation and some antenna setup, you can send your signal through a very long distance. Next, you can do the wireless communication also. Like you don't require any particular wired communication. It will reduce the effect of the noise also. So by using the different, there's effect of noise is also there if you are using a short distance communication. But if you are using a modulation technique, you can do it with the very less effect of the noise. Reduce the height of the antenna. Okay, as the modulation frequency going to increase, then the height of the antenna is also going to be reduces. Okay, that's the another advantages we have. The antenna height should be approximately equal to the wavelength of the signal transmitted. So how we can say reduce the height of the antenna? Let's take if you are transmitting the signal with the kilohertz. Okay, so that height which is going to be approximately equal to the wavelength that you are transmitting. Like we can say if you are transmitting the higher gigahertz frequency, so for that gigahertz frequency your antenna required very low in terms of weight. But if you are sending a kilohertz frequency, equivalent to that you required a very high length of the antenna. And can anybody tell me what is relationship between frequency and wavelength? Anybody tell me what is the relationship between frequency and wavelength? Have you seen this particular equation, which is F equal to, we can say C divided by lambda. So lambda is nothing but your wavelength, F is your frequency. So if your frequency going to be higher, your wavelength is going to be lower because it's inversely proportional. So you can say if lambda is lower and it's directly proportional to the height of your antenna. So we can say higher the frequency, lower the wavelength and lower the antenna height. If you can believe me, like right now, whatever the mobile communication you are doing, which is in megahertz and gigahertz. So if you are using a Bluetooth communication or if you are using a mobile communication, it is in megahertz. So there is height of your antenna or size of your antenna which is near about some of the centimeter only. So in some of the centimeter you can communicate with the direct antenna of your mobile antenna. Okay, so that working on megahertz, it means size of antenna is going to be reduced drastically. Okay, and you can go with the longer distance communication also. Okay, so that's the another advantages you can get it from the modulation. So that is a relationship we have, like wavelength is equal to the V divided by C, we can say, or we can say C divided by V also we can say. Velocity going to be 3 into 10 raised to 8, which is the speed of light. Let's say there is a frequency of 20 kilohertz. So you required a 15,000 meters of the antenna to transmit the 20 kilohertz frequency. But if you are having a frequency going to be 200 megahertz, over here you can see there is a 200 megahertz. So 200 megahertz will require only 1.5 meter of the antenna. So you can see like less frequency, high length of the antenna, while high frequency in megahertz frequency, kilo to megahertz, so frequency increased by 1,000 times. So antenna is going to be reduced by the 1,000 times. Okay, so this is a particular relationship in terms of reducing the antenna height over here. So in the type of modulation, we are having a basically 3 type of the modulation we have: AM modulation, FM modulation, and the phase modulation. Okay. In AM modulation, what is AM? AM is amplitude modulation, as we are discussing since a few minutes. Defined as a process in which amplitude of carrier wave, which is varied in accordance with the instantaneous value of modulating signal. What is the meaning of this particular sentence? We can say like whatever the amplitude of your high frequency signal. Modulating, it's nothing but you are having a very high frequency signal. You are superimposing your low frequency signal over there. Okay, meaning of that, like if your amplitude of your lower frequency signal change, so the amplitude of the high frequency signal also going to be changed. So if amplitude change in lower frequency is reflected in the amplitude change in higher frequency, consider as a amplitude modulation. So that's the meaning of the sentence. Amplitude of the carrier wave is varied in accordance with the instantaneous value of the modulating signal. So generated signal called as a modulated signal. So after the signal getting modulated, it's considered as a modulated signal, carrier signal, and modulating signal. Three type of the signal we have. Okay. So the envelope of the modulated wave has the same shape as the baseband signal. What is the meaning of all particular stuff? So we can go with that one particular animation. Let me go with this particular link so you can better identify what is amplitude modulation. So let me type this link over here. Is this screen is visible to everyone? Anybody please reply. Is this screen is visible?
Yes, sir.
Okay, good. Okay, so this is a stuff. Let's take, this is your F1, which is your high frequency signal. You can say there is a 400 hertz of the signal. Okay, you can increase, you can decrease also. Okay, you can increase also. So 500 hertz of the signal, you are sending a 6 hertz of the signal in that. Let's take, there is a 6 hertz of 10 hertz of the signal. Let's take, you are sending in your particular system 10 hertz of the signal. Okay, so what you can say, this is a lower amplitude, lower frequency signal, this is a high frequency signal, and you are superimposing this signal over here. So you can say if signal is going to be changed their amplitude, you can say this high frequency signal also change their amplitude. Okay, so if I change their signal shape, low frequency signal shape, according to that high frequency will change their value. Okay, you can see like that. Whatever the envelope over here, that envelope is directly, you can reflect it over here in the high frequency wave. Okay, so if you can zoom over here, you can see like that. If that amplitude is going to be vary, if amplitude is going to be vary, that high frequency signal also change their amplitude. Okay, so this is a stuff is going to be happen like this wavelength at this lower frequency wavelength, that high frequency change their amplitude. Okay, these are the stuff you have when you are doing an amplitude modulation in your system. So we can say there is a 500 hertz of the system which is going to be modulated with the 15 hertz. This is a very lower amplitude modulated signal. There's a high, if I may increase my information signal, you can hear the sound over here also. Is that understood over here or not, my friends? Can anybody tell me the feedback? Have you got your idea or not? Like if I'm changing the frequency over here, you can say that entire signal is getting superimposed over here. If you can see this one, so that signal is getting superimposed. So whatever the amplitude multiplication is there, that you can observe over here. Are you getting my point or not? Anybody please reply me. Are you getting the idea?
Yes, sir.
Okay, good. So this is a stuff like that we can consider as a, this is a amplitude modulation we have. Now, if in this particular amplitude modulation, what are the other stuff that we are going to discuss? Let me go with the PPT again. Yes. So what is the AM we have? Like we are having another link also that we can see from this one. So is the screen visible? Okay.
Hi, I'm Brad Callen, and in this video, I'm going to show you how anyone can quickly and easily create doodle videos.
Is that audible? Anybody please reply?
Yes.
Yes, sir.
Okay, good.
Yes, sir.
What is amplitude modulation? That is AM. When the amplitude of high frequency carrier wave is changed in accordance with the intensity of the signal, this process is called amplitude modulation. In the amplitude modulation, only the amplitude of the carrier wave is changed. The frequency and the phase of the carrier wave remains constant. The first visual shows the principle of amplitude modulation. The diagram also shows the audio-electrical signal of frequency Fs. The second visual shows a carrier wave of constant amplitude with frequency Fc. The third visual is the amplitude modulated wave. It is to be noted that the amplitudes of both positive and negative half cycles of carrier waves are changed in accordance with the signal. Thus, the amplitude of the modulated wave possesses the frequency of audio signal waves. Explain frequency modulation, that is FM. When the frequency of carrier wave is changed in accordance with the intensity of the signal, this process is called frequency modulation. In frequency modulation, the amplitude and phase of the carrier wave remains constant. Only the frequency of the carrier wave is changed in accordance with the signal. The frequency variation of the carrier wave depends on the instantaneous amplitude of the signal as shown. When the signal voltage is 0 at A, C, E and G, the carrier frequency is unchanged. When the signal approaches its positive peaks at B and F, the carrier frequency is increased to maximum as shown by closely spaced cycles, but during the negative peak of signal as at D, the carrier frequency is reduced to minimum as shown by widely spaced cycles. The louder signal causes greater frequency change in modulated carrier as indicated by increased bunching and speeding of the waves as compared with relatively weaker signal. The frequency of an FM transmitter without signal input is called the resting frequency or center frequency F0, and this is the allotted frequency of the transmitter. When the signal is applied, the carrier frequency deviates up and down from its resting value F0. The change or shift either above or below the resting frequency is called frequency deviation, del F. The total variation in frequency from the lowest to the highest is called carrier swing, CS. Hence, carrier swing is equal to 2 into frequency deviation. So 2 into del F. For the purposes of FM broadcast, it has been internationally agreed to restrict maximum deviation to 75 kHz on each side of the center frequency for sounds of maximum loudness.
Okay, so yes. So do you get the idea about AM and FM? Like in AM, what we have, like in AM, we are having amplitude is going to be vary with respect to the time in main transmitted signal, while in the FM, that frequency is going to be vary. Okay, let's take, we are having another video link also we have. Let's see what is going to be happen in that one, AM versus FM.
Hello, and this is Sunny. Welcome back. In last video, we talked about modulation and why we need modulation during transmission. Today, we will talk about two modulation methods, amplitude modulation or AM and frequency modulation or FM. Here is the data signal wave we want to transmit. This is the carrier wave with much higher frequency we will use to transmit the data signal. In AM, the amplitude of a carrier wave will change, corresponding to the data signal wave. At the highest point, or peak of the data signal wave, the amplitude of a carrier wave is the strongest. At the lowest point or trough of a data signal wave, the amplitude of a carrier wave is the weakest. From the peak to trough, the modulated wave becomes weaker and weaker. From a trough to a peak, modulated wave becomes stronger and stronger. The result wave's frequency is the same as the carrier wave, only the amplitude is changed. Here is the data signal wave we want to transmit, and this is the carrier wave with much higher frequency we choose to deliver our data signal. In FM, the frequency of the carrier wave will change corresponding to the data signal wave. At the peak of the data signal wave, the frequency of a carrier wave is becoming the highest, while at the lower point of data signal wave, the frequency of a carrier wave is reaching the lowest. From peak to trough, the frequency of a result wave is becoming lower and lower, and from a trough to peak, the result frequency is becoming higher and higher. In FM, the result wave amplitude remains the same, only the frequency is changed. First, AM frequency range is much lower than FM. Thus, AM covers much larger areas than FM. This is the reason why most news stations use AM. But AM is more susceptible to noises because noises affects amplitude. That's why we hear static from AM radio channels. FM frequency range is in a higher spectrum than AM. It can carry more data. Besides, FM is less susceptible to interference. Since the signal is transmitted through changes in frequency, slight changes in amplitude do not matter, and FM receiver can just ignore the changes in amplitude. The result, no static at all. For these two reasons, FM radio channels have a better sound quality. That's why music radio stations tend to choose FM instead of AM. I hope this video.
Okay, so is that any doubt in this question or in this particular video? If you have not understood anything, so that session is open for the question right now. So is there any doubt, any question? If you cannot get any idea like what we are discussing, what is AM, FN and all stuff, you can ask the question, please. Okay, if you have any doubt right now.
Sir,
Yes, miss, tell me.
AM મોડ્યુલેશન હતું,
Okay.
એમાં કેરિયર વેવ શું કહેવા માંગતો હતો?
કેરિયર વેવ વિચ ઇઝ અ હાઈ ફ્રીક્વન્સી સિગ્નલ. જેમ કે હું વાત કરું કે તારી પાસે રેડિયો છે, ઓકે, યુ આર લિસનિંગ ટુ રેડિયો. So radio, there is a specific station is there. Let's take 98.3. Okay, so that 98.3 is what? It's there the carrier frequency. Okay, so જેમ આ વિડીયોમાં છે, હું તને બતાવું ફરી પાછું તો તને બેટર આઈડિયા આવશે. Yes, this is a 500 hertz જે જોશ ને તું, which is a carrier signal. It means a high frequency signal on which your information is going to be transmitted. Okay, like if you can say is a 98.3 megahertz is your radio station, so that 98.3 is your carrier signal, and in that carrier signal you are sending your audio signal through the 75 kilohertz of that particular band. સમજાય છે શું કહું છું તે કે નહીં? Carrier, it means સમજા? Yes, yes.
ના સમજાણું.
ના સમજાણું.
Yes,
Okay,
આ
ફરી
ફિગરમાં
પાછું. ઓકે, એ જુઓ કે આ બે વસ્તુ સમજાણી કે બે સિગ્નલ હોય, એક કેરિયર સિગ્નલ અને એક ઇન્ફોર્મેશન સિગ્નલ. ઓકે, આ 500 હર્ટ્ઝ વાળા છે તારા કેરિયર સિગ્નલ છે. ઓકે, 500 hertz is your carrier signal, which is a high frequency signal of 500 hertz. Okay, just for example, 21.7 hertz. Let's say we are sending at 10 hertz. So 10 hertz signal is your information signal. Let's say you are speaking, just for example, on 10 hertz of the signal. Okay, and 500 hertz that you are using as a carrier signal. So when you are sending the information on the carrier signal in AM modulation, what happened? Your amplitude, your carrier amplitude is vary as per the amplitude of your information signal. તમારું information નું amplitude જે રીતે vary થતું હોય એ રીતે આ carrier signal નું amplitude vary થાય ત્યારે AM modulation થયું કહેવાય. ઓકે, હવે તારો ક્વેશ્ચન છે કે carrier signal એટલે શું? કેરિયર સિગ્નલ એટલે સિમ્પલ હાઈ ફ્રીક્વન્સી સિગ્નલ કે જેના ઉપર તમે તમારી ઇન્ફોર્મેશન સુપર ઇમ્પોઝ કરો છો, કે જેના ઉપર તમારી ઇન્ફોર્મેશન તમે મોડ્યુલેટ કરો છો. ઓકે, કેરિયર સિગ્નલ ઇટ મીન્સ the signal on which your information is going to be superimposed. અહીંયા જોયું જે પ્રમાણેનું સિગ્નલ છે એ પ્રમાણેના આ રીતના હાર્મોનિક્સ બની ગયા. So શું અહીંયા what actually is going to be happen, like this signal is getting overlap on the high frequency carrier signal. સમજાય છે કે નહીં?
Yes.
ઓકે, હવે આ સિગ્નલ ને જો હું ઓછું કેરિયર કરું, ધારો કે 500 નહીં પણ 300 કરું, તો જોયું આ ફ્રીક્વન્સી વેરી થઈ તો આ ફ્રીક્વન્સી પણ વેરી થઈ, બટ ઇન્ફોર્મેશન આ છે તો એમ્પ્લિટ્યુડ સેમ એઝ ઇટ ઇઝ જ રહેશે. ઓકે, તો આ એમ કહી શકું કે આ 300 હર્ટ્ઝ છે તમારું એક રેડિયો સ્ટેશન છે, ઇન્ફોર્મેશન સેમ જ છે, જ્યારે 500 હર્ટ્ઝ છે બીજું રેડિયો સ્ટેશન છે. So we can say AM modulation is going to be same, but just your carrier frequency changing. Okay, so આ એક રેડિયો સ્ટેશન હશે, પછી બીજી ફ્રીક્વન્સી નું બીજું રેડિયો સ્ટેશન હશે, but modulation technique same જ હશે, તો ઈ shape નહીં change થાય, internal frequency going to be changed. Are you getting my point?
Yes.
Okay. And any doubt to anybody? Yes, please. Any doubt, any question? No? Okay, so we will start with our presentation. So how this particular AM modulation is going to be take place? First of all, we need to see that. So this two link we have discussed. Yes, so this is going to be happen like in the AM modulation, you are having one particular baseband signal. Let's take there is your mic. From your mic, there is signal is coming. Okay, your audio signal is coming. Over here, there is a modulator is going to be take. Modulation is nothing but one type of the RLC, that diode transistor based circuit are there, having kind of the RLC component, resistor, inductor, capacitor. There are the components are there, and there is one RF oscillator is there. Let's take you are transmitting through one particular carrier frequency. If I say Radio Mirchi is transmitting with the 98.3 megahertz, it means here there is a RF oscillator which is made up of the 98.3 megahertz. Okay, so whatever the transmitter of the Radio Mirchi station, they have the RF oscillator of the 98.3 megahertz. So it is generating the 98.3 megahertz of the high frequency carrier signal, and on that signal AM modulation is going to be take place, and over here you are getting a modulated signal on 98.3 megahertz. And after that, there is an antenna, RF power amplifier circuit is there. Signal is getting amplified, it is sending to the antenna, and that antenna is situated right now. For your information, let me give you the practical scenario over here. That Radio Mirchi office coming in the Kalava Road. Right now, Radio Mirchi office is at the Kalava Road. If you know about that, there is a pizza center is there. I think Domino's Pizza is there. So above that, there is a Radio Mirchi office is there. So that office is at the Radio Mirchi at the Kalava Road, but signal is going to be transmitted from the Ajidem tower. Have you seen there is a big tower is there in the Ajidem? At the end of our city, there is Ajidem is there. Okay, in Ajidem there is a radio station is there. Doordarshan is broadcasting from there particular area. So over there is a big antenna. If you can climb on any high-rise building in Rajkot, you can see that particular tower, okay, from your roof. So from that tower, two broadcasting is going to be happen. One broadcasting of television, second broadcasting of the radio. Now that television broadcasting, which is from the one level of the particular tower, and another level of the tower, it is broadcasting the radio. Okay, so what actually that person is going to be do in the Radio Mirchi, like from the radio mirchi, they will generate this modulated signal and they will reach those signal to the Ajidem station. Okay, and over that particular station, there is a big height of the antenna is there, and from that antenna, that signal is going to be broadcasted, and that signal is going to be broadcasted in entire city. And whenever you are having any radio phone in your hand, and if you can tune 98.3 megahertz in your radio, you can hear those particular voice over there. Okay, so this process is going to be happen. Whatever the recordings, whatever the shows are there, which is recorded actually at Kalawar Road, but it is going to be transmitted through the one of the end of our city area, and from their location you are getting the signal in entire city. Such type of the process is going to be happen in the AM and FM broadcasting. Okay, so there is one big tower is there that we require to transmit the FM station in entire city. If that size is going to be very large, let's take in Mumbai or let's take in Ahmedabad, if size of that radio station or size of the city is very high, that area is very high, so we require the multiple antennas, okay, to broadcast the same information. Okay, that stuff is required. But if for the lower area of the city, 10-15 kilometer, one antenna is going to be sufficient. Okay, so whenever you have the chance to visit over there, you can see there is a big size of the antenna is there. One sided there is a television studio is there, Doordarshan studio is there, so they are doing this all particular stuff. Okay, transmitting, recording, and the broadcasting. So this is a stuff is going to be happen. Like over here there is a high frequency carrier signal is coming. Over here there is your actual information signal is coming. In AM modulator, such type of the output signal is going to be generating from your particular system. Okay, these are the stuff we have. So this is the AM waveform. That's such type of the waveform that we have already discussed. This is the overall amplitude modulated signal. There are the several parameters are there. Like there is a maximum amplitude are there, minimum amplitude are there. There is an envelope of the modulated signal are there. That amplitude is going to be changing AM plus AC. So AM, it means that modulating signal, AC is a carrier signal. So there is an amplitude of modulation plus amplitude of carrier signal is equal to the amplitude of overall modulated signal over here. Okay, so this stuff is going to be defined and several parameters are there in terms of AM modulation. Another stuff we have, which is considered as a parameter, name as a modulation index. Okay, modulation index is nothing but is a ratio of amplitude of modulating signal and amplitude of the carrier signal. In another word, you can say AM is a maximum amplitude of the message signal, and AC is nothing but maximum amplitude of the carrier signal. If you are taking a ratio of both of them, you can identify the modulation index. And where this modulation index is required, modulation index will identify whether signal is going to be distortion or it's not having any distortion. So we can say maximum amplitude of the message signal must be less than the maximum amplitude of the carrier signal. Okay, amplitude of the carrier signal to avoid the distortion in the modulation. Now, what is the meaning of that? If you can go back to this one, like we can say if that amplitude of this particular signal is going to be higher, let's take your carrier signal is amplitude is going to be higher, and modulation signal also that information signal also having the higher modulation than this one. So we can say overall modulation is going to be successfully taken. But if that modulation is going to be mismatched, if amplitude is going to be mismatched, then interference is going to be occur. So what is in terms of interference? That interference is going to be defined with the, or we can say modulation index is defined in terms of the three parameter: perfect modulation, under modulation, and over modulation. Now what is this perfect, under, and over modulation? This is a stuff we have. So first we can say first is a perfect modulation. Now perfect modulation occurs when, okay, listen carefully, perfect modulation occurs when maximum amplitude of the message signal or modulating signal is exactly equal to the maximum amplitude of carrier signal. So you can say carrier signal amplitude and information signal amplitude, if both going to be same, then your modulation is considered as a perfect modulation and your modulation index is going to be 1. How we can say it's going to be 1? from this previous equation. Like if both going to be same, so we can say ratio equal to 1 we have. And how the signal will look like? Signal is going to be look like this one. So we can say this above envelope and below envelope, positive and negative envelope, both going to be touch, or it's going, we can say that negative signal is going to be touch over here at the center of the particular axis. Okay, so this is a perfect modulation we have. If we can say under modulation, it means like amplitude of your carrier signal, which is going to be greater than the amplitude of your message signal, then which is considered as under modulation. So in under modulation, we can say there is an example over here, like message signal information is 2 volt, while carrier signal is having a 4 volt. So we can say carrier signal having the higher amplitude, while signal, a message signal having a lower amplitude. If you are modulating such type of the system, then it is considered as under modulation. You can see that both of that lower value of the both of the side not going to be touch over here. So we can say if it is not touch, it means under modulation. If it is touch, then there is a perfect modulation. And if it's going to be cross to each other, like in the third scenario, we can say this is going to be happen when your message signal amplitude is greater than your carrier signal amplitude, then it is considered as a over modulation. For example, let's take your message signal is the 6 volt and carrier signal is a 4 volt. So we can say modulation index is 6 by 4. We can say it's 1 by 5, 1.5. So we can say modulation index going to be greater than 1. And in this particular case, your interference is going to be occur very high in manner. So whenever we are doing a modulation, we need to take account that like modulation index maximum, it should be either under modulation or it's going to be perfect modulation. Okay, such type of the stuff you need to keep in mind whenever you are using a such type of the modulation scheme. Okay, so that amplitude also need to be choose properly. Okay, to identify that every stuff which is going to be work proper in manner. Any doubt in this one, in under modulation, over modulation, or the perfect modulation? Any issue over here? So what we can do, like it's already 1 hour we have, so we will take a little bit of the 5 minute of the break. I will drink the water. You will also put your eyes just a little bit away from the computer or mobile screen, and then after we will meet in just 5 minutes of the break. Till now, just revise whatever the stuff that we have discussed till now. Okay. So refresh yourself. We will again come back in just 5 minutes. Okay, so I'm back. Is everybody ready? Is everybody here? Okay, so let's start with the next topic, or continue with that type of the modulation index. And we can say there is a three type we have discussed: over, perfect, and under. Okay, always we require that your modulation is going to be under modulation or the perfect modulation. We are not allowed to do that modulation which is going to be over. Then it's creating the interference that we have discussed now. Now we can say that what are the applications of the AM modulation we have, where you can see this modulation. So you can see this modulation in air band radio. In aerospace industries, we are using amplitude modulation. Broadcasting transmission is used for short or medium or long wave band. Like if you are transmitting your video channel, like whenever you are transmitting your video system, or we can say your television system. So in television system, mostly we are using a AM modulation as a primary kind of the technique to send the signal through the longer distance. So in television broadcasting, we are using a AM modulation, as well as in the air band in aerospace industries, we are using AM modulation, as well as a signal sideband, the amplitude modulation in form of the single sideband still used in a HF radio links. Now there is a different stuff we have. We can say sideband modulation we have. So it's going to be very detailed type of the stuff we have. Like whenever we are discussing about the stuff, like it is having a single sideband, multiple sideband, as well as there is a sideband with the carrier going to be missed. So there are the several type of the AM modulation technique also is going to be there, through which we can do the all the stuff type of the communication over here. So in AM mostly it is used with the sideband, very huge band we required to send the any audio modulated signal. Okay. Let's take there is advantages and disadvantages of the AM modulation we have. So there is a first advantages, which is a simple modular circuit. Okay, we required a very simple circuit like diode and transistor based circuit. If you can put, you can do the AM modulation easily. It's a cost effective, like it's a low cost, and which we can say it's a low quality in terms of modulation also there. So commercial broadcasting of audio video signal, AM modulation is going to be very good for that. It is also like that it can be demodulated using a circuit consisting of very few components. So as the modulation is going to be easy, like to demodulate it, it's also going to be easy. So both your transmitter and receiver can make easily with the fewer amount of the component. Advantages is there poor performance due to the noise. Like noise is going to be affected as compared to the FM modulation. So that AM is very having a big drawback in terms of noise handling. Inefficient use of transmitted power. Okay, that power is not going to be used effectively because power is going to be fluctuating continuously. So we can say it's going to be not using a sufficient amount of the power with that. Okay, it is not efficient in terms of use of bandwidth, requiring a bandwidth equal to the twice of the highest audio frequency. Okay, if I'll give the example of the television band, it's consumed the 7 megahertz of the band to transmit the one particular channel. Okay, after the lots of modification, it is required 7 megahertz of the band. So proper utilization of the band, it's sometimes there is a questionable over here, and it required a very high bandwidth to transmit the AM signal. So that's some of the disadvantages over here. Another different type of the AM, as I have discussed just a few minutes back, there are the types of the AM also we have. So there is a DSB, FC is there, double sideband full carrier. So name itself suggests double sideband full carrier. It means there is a two sideband are there. Let me, if I can draw over here so you can get the better idea. Let's say there is a main carrier frequency is there, and there is a two sideband frequencies there. If we can plot this one with respect to the frequency, if we can say there is a frequency, and if there is an amplitude you have. So we can see in amplitude and frequency, there is a double sideband full carrier. We can say whatever the modulation you are doing, it having the three component. There is a carrier is there, and there is a sideband is there, two sidebands, sideband 1 and there is a sideband 2. So we can say both sideband is present. We can say there is a double sideband full carrier, which is the first one, which is having all these three components. Double sideband substrate carrier. Double sideband substrate carrier, it means the C is not going to be available. Okay. C is not going to be available and only S1 and S2 is available in your system. Then we can say it's a DSB SC type of the communication system. Like single sideband substrate carrier. Single sideband substrate carrier, it means out of this two carrier, only one carrier is going to be transmitted. Let's take either S2 or S1. So S1 is all not going to be there, or either S2 is not going to be there, and carrier is also not going to be there. So such type of the single sideband substrate carrier type of the modulation scheme is also going to be there. So out of the three component, depending on that, what are the particular component you have, whether it is having all the sideband and carrier, then we can say it's kind of the modulation technique. Either one carrier is there, or either there is a carrier is substrate, only sideband is there. Such type of the stuff is going. Now my general question is that how this stuff is going to be generated. Where this stuff is going to be generated due to that, like you can say, let's take you are transmitting with the 500 hertz of the carrier frequency you have, and you can say you are having a information signal which is vary up to the 20 kilohertz. Okay, so information is having a 20 hertz while your carrier is 500 hertz. So we can say just a 20 hertz this side and 20 hertz this side. So we can say this is going to be 520 and this is going to be 480. So we can say you are having a one carrier that's S1, we can say one sideband at the 480, another sideband at the 520, and your main carrier at the 500. So such type of the band is created depend upon the frequency of your information signal. So depend upon the frequency of your information signal, such type of the sideband is going to be covered. And in that sideband, after the getting the sideband, you are applying a different type of the modulation technique over here. Okay. Is that clear? Any doubt? So you can ask the question over here. So what we are doing in a multi-sim circuit, like first we are setting the signal source from the frequency, which is equal to the last two digit of your enrollment number, like such type of the stuff you are going to do. Set the carrier frequency on function generator of last digit of your enrollment number in kilohertz. Observe the AM envelope in the CRO, that type of the stuff you need to do. And vary the waveform type, sinusoidal, square, triangular, and you need to observe what are the stuff is going to be coming out. So this stuff we are going to be do, but what is the result that is going to be happen? So this type of the setup, when you are having a multi-sim in your next lecture, you need to do this such type of the stuff. There is one oscillator is there, which is having actually there is a 4-channel oscillator, we can say. Over here there is a function generator is there, as well as there is one particular source is there. So in signal source you need to generate one frequency. From the function generator also you need to generate one frequency. You need to use the multiplier which is available in the multisim, and whatever the signal coming out from the multiplier you need to observe over here. Okay, such type of the stuff is going to be there in your multisim experiment. Very simple one. So what you can observe, you can observe the such type of the modulated signal in your system. Okay, so that will give you the simple, like by using a modulating circuit, you can do that particular stuff over here. What is a demodulator? If you can see, or if you can go with that demodulator over here. So we can say, like whenever we are having a demodulator, so two stuff is going to be there. Like first stuff, which is an envelope detector, two method. Second is a product detector. Okay, so demodulation is nothing but the reverse process of the modulation. Like in modulation, we have superimpose our particular stuff, our information into the carrier signal, while in the demodulation, we will retrieve back those information. Okay. Now, in this process of detection of that modulated signal means we are recurring the signal from the modulating signal. Okay. So since the envelope of AM wave is the same shape of our message signal, so we can say it is not going to be that much of difficult to identify their carrier frequency and phase. Okay, so just by extracting that particular envelope, we can identify our actual information signal over here. So what is the stuff we have? First stuff, which is an envelope detector. Envelope detector, simple stuff, you can say. There are one diode is there is one capacitor is there, and there is one resistor is there. Can anybody tell me what do you mean by this particular circuit? What this circuit is going to be tell us? Diode and capacitor. Have you seen such circuit in basic electronics? Nobody is giving me the answer. Just sitting ideally.
सर क्लिपर या क्लैंपर में से कुछ होता है
Yes,
ऐसा?
right. That circuit is considered as a clipper or clamper. Okay, so this is a one type of the resistor and capacitor based circuit, which is work as a clipper. Clip, it means which will clip the half of the signal. Okay, which will clip the half of the signal which is above the sum of the particular frequency or sum of the voltage level. So whenever you are applying such type of the clipper circuit and the resistor, it will automatically give the output such similar type of the envelope wave out of that. Okay, that stuff is going to be directly, you can get it from the envelope detector circuit. We can say like that, what is in the envelope circuit, if we can identify that multisim circuit of that. So instead of applying the half wave, we are applying kind of the full wave. Like we are having a two-sided diode we have, so we can say there is a center tap type of the arrangement, and we are applying the two diode. First diode will work in the positive cycle, second diode will work in the negative cycle. So by applying the multiplier with the same function generator circuit and with the source we have, we can generate the such type of the circuit in your multi-stream, and you can identify the output which is look like this one. Okay, so if we can having a such type of the like now right now we are having a multiplier, it means already over here there is a modulated signal you have. So over here you are having an AM signal already there, but by attaching this circuit like with this one diode, capacitor and resistor, that AM wave is going to be demodulated and it's going to be reflected in the output channel, and it's going to be reflected as a actual signal that you have transmitted from your system. Okay, so that is the advantages you can get it if you are having a simple diode, capacitor and resistor based circuit you have. Okay, next we have the product detector. In product detector, what are the stuff we have? It's a type of demodulator used in AM. Rather than converting the envelope of this signal into the decoded waveform, envelope, it's done in envelope detector. It takes the product of the modulating signal and the local oscillator frequency to detect the modulating signal. Again, like we can say modulating signal you have already, and it is going to be again modulated with the local oscillator frequency that you have used the same at your transmitter side. So we can say in the simple example, this is a stuff is there. So product detector, it means over here there is an input signal which is already modulated signal you have. Again, you are using a multiplier with the same sinusoidal carrier frequency, and you are getting the output signal as a original that you have previously transmitted over there. So what is going to be happen? Like what is going to be happen in product detector, you can say in product detector, whatever the amplitude you have, like let's take the example, if you are transmitted with the 1 kilohertz of the frequency, if you are using the same frequency and if that amplitude is going to be slightly vary, let's take whenever there is a maximum amplitude, you are using a minimum amplitude of that one, or we can say negative cycle of that one. So simply just making this little bit shift at the receiver side, you can actually detect the actual signal that you have transmitted. Like we can say, just for the example, let me give you the brief idea. Let's say you are having a signal like this one. Now, if you are just multiplying the signal with this one, so we can say the product of that one is become the 0. Okay, so and it's already signal is going to be modulated with the actual kind of the original signal. when this negative amount of this sinusoidal carrier is multiplied with that, so in the output, like over here, there is a signal which is going to be like this one. Let me draw over here first. And the another side, which is going to be like this one. And over here, we can say there is a high frequency. That's the signal is going to be there. If you can, that my drawing is so much bad, but just imagine that what is the amplitude modulation we have discussed over here. Now we can say over here, it's a zero. Over here, let's take there is a maximum amplitude you have. Now with this particular signal, if you are multiply the same carrier signal with the same frequency, but little bit of that one, which is going to be out of the phase. Like whenever there is a positive is there, you are entering over here local oscillator negative with that. So if signal is going to be positive over here, so from the local oscillator, it is coming the negative like that one. So product of that which will lead you towards the envelope which is going to be overlap over here. So that envelope you can easily detect when you are having a slightly out of the phase same carrier frequency we have. And same thing is going to be happen in your radio also. Like we can say what is going to be happen in your radio. In radio you can say like you are tuning your particular station. Like we can say there is a 98.3 FM. If you want to listen the radio Mirchi, what you need to do, you need to tune that particular station. So until and unless if you are not tuning that particular station, you cannot detect the direct frequency. So what you are doing inside of your receiver radio, you are artificially generating another carrier frequency which going to be multiplied with the actual signal and give you the FM output as a audio signal from your particular loudspeaker. So that reverse process is going to be take place during the demodulation. Now over here there is one quiz is there. Let's take an amplitude modulation, the instantaneous value of carrier amplitude change accordance with the amplitude of the frequency variation of the modulation signal, true or false? Amplitude modulation, the instantaneous value of carrier amplitude change in accordance with the amplitude of the frequency variation of the modulating signal, true or false? Can anybody tell me? It's true. That's the standard definition of the amplitude modulation. Second, what is a line connecting the positive and negative peak of the carrier waveform cold? What is a line connecting the positive and negative peak of the carrier waveform cold? Any guess? Any idea? No response at all? It's called the envelope of the AM modulation signal. What is the percentage of the modulation if the modulating signal is 7.5 volt and carrier is of 9 volt? You need to calculate this one and you need to show it to me. What is the percentage of modulation if modulating signal is 7.5 volt and carrier signal is 9 volt? It's going to be 83.3. And how you can get this 83.3? You can get this 83.3 by just dividing 7.5. Simply you can get it by taking the ratio of 7.5 divided by 9. This is nothing but the modulation index, and from that you can identify the percentage, which is 83.3. So it is 83.3. So either it is under modulation, over modulation, or perfect modulation.
So under?
Yes, right. It's under modulation because it's less than 100. So we can say it's a under modulation. If it is 100, then perfect modulation, and if it is more than that, then it's going to be over modulation. Correct. So what is the condition for greatest output power at the transmitter without the distortion? Without the distortion, what we need to take care? Modulating signal voltage greater than the carrier voltage, modulating signal voltage less than the carrier signal voltage, or modulating signal voltage equal to carrier voltage, or modulating signal voltage equal to 0. Ideal condition, we are having answer which is going to be equal. Modulating signal voltage equal to the carrier voltage, we can say this is going to be a perfect modulation scheme we have, or we can say in lower case of that, under modulation also the signal is going to be transmitted without distortion. But if you are having a equal, both amplitude is going to be equal, then without distortion that signal is going to be transmitted perfectly. Any doubt in this one? If you have not understood, okay. So this is overall discussion of the AM modulation till now. Any doubt? Now question open for all of you. Any doubt, any question right now you have? Or if I'll ask the question to a particular person. And frankly speaking, my friends, whatever the stuff you are doing right now, I don't know about that. Whatever the stuff you are either see this lecture or not, are you attending this lecture or not, are you willing to do that particular stuff or not, that's not going to be my issue, my friend. It's my humble request that please pay attention and participate in the discussion. We are not just, I'm not like a robot, like speaking and just you are listening, not giving the feedback, not in even in terms of yes, no, okay, agree. Lots of people are not participating even. Are you afraid of something speaking in front of this mic? If you are giving me the feedback, like whether you are getting this stuff or not, are you understanding or not, then it is very easy for all the levels in terms of examination and all stuff. Yes, last question having the doubt. Okay. So what is the stuff we have? Let me go again with that. Yes. So in last question, what we have, modulating signal equal to the carrier voltage. So if we can go a little bit over here, let me, yes, this. So over here, this is a stuff is a right answer. We can say whenever both amplitude is going to be same, at that time there is a no distortion is there. It means whatever the overall amplitude is going to be there, which is touch at the center. So we can say there is no such type of the intermediate distortion is there. In under modulation or in the over modulation, we are having a distortion is there. Like there is a little bit amount of the mismatch over here in terms of amplitude, as well as there is a little bit amount of the over modulation over here. So this both stuff will create a distortion, like distortion in terms of this will create a complete distortion. This will having a little bit of distortion as compared to the perfect modulation. So we can say, if we can say the perfect modulation, which is a technique which will give you the kind of the zero distortion type of the amplitude scheme you have in the perfect modulation scheme. If that amplitude is not going to be matched, it means that amount of amplitude which is going to be wasted, okay, in terms of transmission. So that particular stuff will create a kind of the distortion when you are transmitting the signal into the air, okay. If it is going to be matched, we can say you can say entire envelope is going to be superimposed in your carrier signal. So that's going to be a perfect thing. Both amplitude is going to be matched. We can say when there is a perfect amplitude, it means your carrier amplitude and your signal amplitude both going to be matched. If both going to be matched, then not creating the distortion. If not going to be matched, then it is create a distortion. So it's not going to be matched. When it is going to be considered not going to be matched, either your carrier signal amplitude higher, less than your modulating signal, or your information signal amplitude is higher as compared to the carrier signal. In both case, amplitude is not matched and the distortion is going to be occur. So this is a case we have, and we have asked the question accordingly, like when we can say there is a greatest output power you have without the distortion. While there is a greatest output power, because both amplitude is going to be matched over there, and due to that, maximum power output you can get it in that particular condition. Is that okay, or am I conveyed properly or not, Misal? Am I clear with your answer, with your query, or not? Please reply. Hello? Okay, no doubt. Okay. Now, what we are going to do, that as I have promised, now I'm going to start the installation of that particular multisim. So it is required that in the next lab you should install this particular stuff in your laptop, or if there is a PC available at your stuff. But we required to. Hello, my voice is clear or not? Anybody, please reply. My voice is clear or not?
Yes, sir.
Okay. So let's start with the installation of the multisim, and this link we have, like whatever this particular multisim link is there. I will share this link to your. Are you having any WhatsApp group right now, which is from where that actually information is sharing? Are we having any WhatsApp group or not? Hello. So if you have any WhatsApp group, so kindly add me on that, because I will share this particular software in that particular WhatsApp link. One drive link is there, and from the drive link you can easily download this multisim software. Is it okay? Okay. So now let me start with the installation. So once you will install that particular stuff, you need to extract. And is that screen is visible? Anybody please reply over here.
Yes, sir.
Okay.
Yes, sir.
So over there, just you need to just click on the setup.exe. Just you need to either with the serial number. Let's say you need to start with the evolution product. With the evolution, you need to start with this one. Okay, or yes, you need to start with this one. Install this product with the evolution. You need to click on next, next, next. Right now, you need to just click next. You need to untick over here, accept, next, next, and you need to wait for a few minutes. Till now, any doubt in the DCN? Now it's installing, and after that I will also tell you like how you can install the license file also. Like, are you having any doubt or any question right now? Because
Hello,
I am.
sir.
Yes, please.
सर इंस्टॉलेशन के बाद एक की मांगता है.
Okay. So after that, initially we are not installing the key. After that, we are having a separate license manager is there. Through that, you can install the key. Okay. So I will explain it again. Installing the keys. Okay. Any doubt till now? Like right now that we are. You have already done a lots of lecture. You have attended lots of stuff is there. If you have any doubt, any question, you can ask me right now. Okay, regarding the DCN, any damn question in entire syllabus that you have gone up till now. Hello? Any question or any stuff that you have doubt or any stuff that you have not understood till now in entire DCN subject? Any question? For the Ubuntu, right now that software is available for the Windows only. Let me search the setup file for the Ubuntu also, and if it is available, then I will share it with you. Otherwise, that laboratory facility, like we are having a lab over here, and I think Shreyas sir has already shared link or that number of that particular madam. Okay, so you can contact to that madam and she will open that system for you, and you can do your experiment over that also in virtually manner or by using any I think team viewer they are using, okay, for the communication. So you can install the team viewer, and from that PC also you can perform your experiment. Okay, if that Ubuntu file is not available, let me search first. If it is not available, then we can go with that alternative. Any other question, any other query or idea? Okay, Mr. Meanwhile, this installation is going to be complete. It's 99% right now overall progress. It is just finishing. Few seconds. Okay, next. Now, what we need to do, we are not restart later. What we need to do, you just need to go to that license activator. You need to click on this multi-sim. The full edition, you need to click over here. You need to activate. Just you need to press activate, and that's it. Let's start the multi-sim. If it is run, then our task is over. Yes, now it is run. Okay. So let me open some of the file. It's very easy installation, and let me open some of the file that right now, which is for the AM modulation. I already downloaded them. Yes. So let me open this file, and let me open it from download. Okay, it's MS14. Okay, so that we have installed multisim. It's 13, it's 14, so we can say that's the issue here, but not a problem at all. What we can do, we will do with that particular process. Let me do it over here for you, so you can repeat those particular process by looking to this particular video. So let me go with that PPT, and yes, in the amplitude modulation, having the circuit. Yes, this is the circuit we have. Okay, so we require function generator, multiplier, source, and the oscillator. Okay, so let me take this particular stuff one by one. Having the component. Okay, so in this component, you can search over here from the all the families, or you can search it from the individual component wise also. So what we required first, as per the amplitude, we require the function generator. So function generator, we can take it. Over here, there's a different meter and generator and all the stuff we have. So we can say this is a function generator we have. Let me zoom this little bit so you can get the better idea. Oh, sorry. Okay, so this is one function generator we have taken as per the PPT is showing, and we need to take one AC source. Okay, signal source we need to take. So we will go with that source. You can say, let's take, there are the different source we have, like this source we can take. Okay, so this is one source we have taken, as well as we required one ground also there. We will take one ground from this one. This is the ground we have taken. I will connect this ground over here. Now I required another stuff, which is a multiplier. So I can go to this stuff. Is the screen is visible to everybody or not?
Yes, sir.
Okay, that's the good. Yes, there is a multiplier is there. We will put the multiplier over here. Then what we required the one oscilloscope. So where is the oscilloscope? Multimeter, there is an oscilloscope here. We will take a 2-channel oscilloscope, okay? Not to issue. You can take 4-channel also, but I'm taking a 3-channel over, 2-channel over here. One also ground, one ground we required over here also. So let me connect this ground to first this one. Sorry. Then I will connect the ground to this also. And where is the connection? One connection from plus is going to the Y over here, and one connection which is going to, oh sorry, I need to connect this, this stuff is connected wrongly. Okay. So I need to connect this ground to the middle one because I require the positive amplitude, that's why. Okay, so this X is going to be connected over here. Then I can go with that channel is the one extra ground I also required. So I will put one ground over here. Okay, the ground I will connect this stuff, and I will connect this particular output over here. Okay, so let's first of all save this stuff. It's AM modulator. Now over here, we'll run it. First of all, we need to set the frequency also. Okay, so let's take. I'm taking a frequency. Let's take 1000 hertz. Okay, and waveform is going to be sinusoidal. Voltage is going to be 10 volt. Okay, let me take. There is a hertz. Let's take. There is a 50 hertz, and amplitude is going to be also the 10 volt. Over here, let's first of all check. We are having a 10 volt over here, so both are having a 10 volt. So we are required. We can consider that this is a perfect modulation is going to be possible. Okay, so if we can see this particular diagram, and if we can run it, and if we can just let me just make the screen bigger. And if we can reverse this particular stuff, if I can download, we can set down, make this scale little bit of down, make it little bit of up. If we can make this little bit of down, oh sorry, I need to do it little bit of lower. Yes. So this is the stuff we have that you can. Yes, this is an amplitude modulation signal that you can observe. Now this is an amplitude modulated signal we have. Okay, and if we can go with the let's take, if we can go with the both of the signals. So right now this is a modulated signal you have got over here. Okay, and you can see this is a perfect matching over here. You can say there is a perfect matching type of the modulating scheme is going to be achieved over here. So we can say if I can add the another channel, let's take I'm adding the another channel over here. But before going to end that, I need to stop this particular system. And another channel, what I will add the channel which is actually I'm inserting actual signal that I'm giving over here. Let's say I'm giving the signal from the source. I'm again connecting this stuff to the second terminal to the ground over here. Now if I can play this one. So I'm having the another, first of all, for your information, I need to change the color. Make sure like right now both are in the red color. So we can say signal also you can observe as a red only. But if you can change the color of that particular wire, so you can observe the different signal. You can say there is another signal also we have. And we can say why I need to change the both of them. B is also there. Sorry. y of t. If I'll go with that channel, yeah, so you can see like that. Okay, so this is the information we have. Like right now, there's a 5 volt per division. If I can go with the 100 volt per division. Okay, so if we can just shift a little bit, like we can say whatever the second channel we have, if you can just change your position over here, so you can see like that such type of the envelope is going to be created over here. Okay, and just a second. Yes, we can say such type of the envelope is going to be created, and according to that, it's going to work over here. Okay, so that same stuff that we are discussing in our theory, like whatever the modulation you have, you can see, like if I can make both with the equal voltage per division, 100 volt per division, and I can put it just little bit of lower. So what is going to be happen, like we are having amplitude of amplitude of that signal also, which is near about 10 volt, as well as we are having amplitude of the carrier also, which is also going to be 10 volts. Overall, whatever the signal is going to be made over here, which is going to be changed into 20 volt stuff we have. So we can say it's equal to the double of that particular size. Now, if we can just stop over here, and if we can say, let's take I'm changing something. Let's take I'm changing from 50 hertz. Let's take I'm changing to 10 hertz. Okay. If I'm changing to 10 hertz, you can see there is a difference is going to be happen in the envelope. Okay, so that same stuff that we have discussed previously also. Like if you are changing the frequency of your particular input signal, so according to that, your signal is also going to be changed there, envelope tracing. If I'll go with the higher one, let's take instead of 50, if I'm taking 100, so we can say envelope is also going to be created accordingly, 100. Okay, and as for the stuff that we have discussed, like in the function generator also, if you can change from 1000 hertz to let's take 2000 hertz, so we can say with that particular setting also, you can see that internal carrier frequency also going to be changed. But over here, frequencies that signal amplitude and signal waveform is going to be as it is. So this is a difference you can observe in this particular screen. Okay. Another stuff that is asked in the particular stuff, if you can change your signal from sinusoidal wave to, let's take, there is a square wave. In the square wave, if you can generate your particular modulating signal, you can see this is a squared type of the stuff which is going to be generated over here. Let me just zoom it more. You can see there is a squared signal we have. Okay, so that squared signal considered as an amplitude carrier frequency, and according to that, that modulating envelope is going to be generating over here. Furthermore, if you can go with the triangular wave, so that signal is going to become according to that triangular wave that you have chosen of that particular frequency. We can say such type of the triangular wave come. Okay, so this is the simple stuff you have, which is going to be possible when you are using such type of the modulation diagram, which is a very simple, like we require the modulator diagram over here, and that modulator diagram you can do it with very easy type of stuff. Any doubt over here, my friends? Any doubt, any question? I have demonstrated how this circuit is going to be implemented and how this circuit is going to be identify or analyze their output. Similar, your task is there, you can identify the output of the another circuit that is defined in this PPT, like about this demodulator circuit, envelope detector circuit. You can make this circuit arrangement and you can do the demodulator experiment over there also. Okay, so it's very easy, not a very big task. I'm leaving on you, like this stuff we are going to do in the next lecture also. You need to come up with the multisim install, but how to install the multisim and that particular stuff you can see from this video recorded lecture, which is going to be uploaded today evening. Okay, any doubt, any question till now, my friend? I hope I am clear with that particular practical and how to connect this all circuit and all stuff. Any doubt, any question? I required from your side, like add me on one of the WhatsApp group, and I will share the drive link over there, and you can install from that particular drive link. Is that okay? Any doubt in this one? Installation and all stuff. I hope that choice filling, like we have float one particular sheet about the rubric on demand. I hope all of you have fill your choice in that rubric on demand. If you have not accessed those particular link, you can you have not fill or you have no doubt. Srenik, let me show it to you in the canvas. In Canvas, right now we have floated one quiz also there. I hope you have attended those quiz also. As well as I have float one announcement also about the rubric on demand. And on the rubric on demand related task, we are going to start in this before this weekend. So those who have not fill your choice, I request you need to fill your choice in the rubric on demand. If you will go to the canvas, there is one announcement is there. In the announcement, you can go to this particular post, and in that post at the end you can see this instruction, and there is one link is there. Over here there is one link is there. You can copy this particular link in your web page, and in that web page there is a one choice in front of your name, in front of your enrollment. You need to fill your choice, like out of this all the 5 rubric on demand, which rubric you want to adopt. Okay, and according to that we will allocate one faculty, we will guide you, and then there is according to that task you need to perform before the end of the semester, and it will contain a 25 marks. Okay, so do it as early as possible, those who have not done, because we are going to start the exercise on this one from the next week onwards. Any doubt in this one, in this particular stuff?
सर इसमें जो कोड वाला ऑप्शन है उसमें कोड की डिफिकल्टी क्या होगी?
Not that much. Let's take, I will give the example like that. अभी आपने ये मॉड्यूलेटर भी सीखा, ओके? तो अभी आप ऐसा करो कि लाइक आप कौन सी फ्रीक्वेंसी का सिग्नल जनरेट करना चाहते हो, तो आप वो सिग्नल फ्रीक्वेंसी आप दे दो भाई 10, 20, 30, आप ऐसा प्री डिफाइन ऐसा कोई सिग्नल ऐसा वेवफॉर्म बनाओ, तो बंदा यूजर डिफाइन चूज करे भाई मैं कैरियर फ्रीक्वेंसी 100 लेना चाहता हूँ, सिग्नल फ्रीक्वेंसी 10 लेना, तो आपका मॉड्यूलेशन कैसा होगा? लाइक on the back end side you need to decide your code which will make it possible. अभी आप उसको C++ कैसे वेवफॉर्म है, 10 किलोहर्ट्ज का वेवफॉर्म है तो ऐसा दिखना चाहिए, 100 का है तो ऐसा दिखना चाहिए. लाइकवाइज द कोड यू नीड टू डेवलप. ओके, एक चीज बना ली, उसको सिर्फ आपको रिपीट करना है अलग अलग वेरिएंट के लिए. इट्स नॉट लाइक दैट मच ऑफ द वेरी डिफिकल्ट कोड, लाइक आप पॉइंटर में जाओ और ये फाइल को कॉल करो, वहां से डिसीजन लो, ऐसा heavy we are not going to expect from your side. But whatever the task we are allocating to you, that task you need to fulfill, whatever the type of the code you can do. Okay, whether it's completed with the easy in manner, we are not having any issue with that. Our task is, or our criteria is that that task need to be done. Okay,
और सर टॉपिक
am I clear?
टॉपिक कब मिलेगा?
First give your choice. After that how many choices are there, according to that topic we will decide, and the one faculty will dedicate it to you. Out of our 5 faculty, one faculty give it to you, and you need to report to that faculty. You need to submit all this stuff to that faculty, and you can take the your project ID or that your project title from that faculty also. We will share each and everything. First give your choice. After that, depend on how many students are participating in which particular area. According to that, we will identify the task. Previously, we have 30 to 40 tasks are there, minimum task we have, that already your senior has done. So according to that, from their task or new task, we will give it to you. Okay? Any doubt in this one? Any doubt, any questions? No questions? So there is a 10 minute is open for all of you. You can write down your enrollment number and you can leave also, as well as if you are having any doubt, you can discuss with me in this 10 minute of the particular time. Those who have not any particular doubt, they can write their enrollment number and they can leave the session. But my friend, I request all of you that please participate in the each and every discussion, give your opinion, whether it is right or wrong or whatever the damn questions are there, just ask me. Okay, it's a very good stuff with us, such type of the platform. So please give your feedback. Otherwise, it is not going to be worked properly. Those who have doubt, any question, they can ask right now. If you have not any doubt, you can leave and start installing this particular oh, I have not said with you. So if you can, if you have that number of that madam, you can call them and ask them to start that particular PC. So she can start and you can perform this experiment over there also. Okay, my number is going to be there. Let me write down my number. If possible, call me before 8 o'clock or 8:30 o'clock, because after that we need to give the time for the family also. So please call me before 8:30. If very emergency is there, then you can call me after that also. But kindly think about that privacy also, if it is possible. Okay, those who have not any doubt, any particular stuff, they can leave the meeting and they can end this session and wait for the next lecture, if it is there. Yes, Hetal, Sranik, any doubt?